Welcome students, this is again Ravi Shankar meeting you through the next video. See, in our last video we have studied about the electrical field. We have completed the electrical field and now we have to go with some of the problems regarding the electrical field. First of all, we will go through the example problems. There are 3 example problems that were being dealt in your book. Let us consider the first example problem, that is example 1.6 based on the electrical field in page number 13. Not 1.6, it is available in the page number 13. So let us go with, this is not 1.6, this is page number 13. See, what is the problem? You just go through the problem. It was given, calculate the electrical field at points P, Q for the following 2 cases as shown in the figure. They have given 2 diagrams, one is A and another one is B. In A, at the origin, they have placed a charge plus 1 microcoulomb. They have considered 2 points. One of the point is P and another point is Q. So at this point, what is the electrical field? We have to calculate EP vector. Similarly, at this point Q, due to this charge plus 1 microcoulomb, we have to calculate that. We are calling it out as EQ vector. So 2 problems has to be solved for the subdivision A. Similarly, for the subdivision B, you are having at the origin O, you are having a charge minus 2 microcoulomb. 2 points are considered. One is point P and another one is point Q. Point P, we have to calculate the electrical field. Let us be EP. Similarly, at point Q, we have to calculate what is this EQ. Both magnitude and the direction. Here we have to get answers for 2 questions and here we have to get answers for 2 questions. So totally 4 solutions has to be got. So again, let us consider the solution. See, when you are considering the solution, first of all, I am taking the first subdivision A. I am again considering the diagram. So this is x-axis, this is y-axis. At this origin, I am having a charge plus 1 microcoulomb. 2 points, one of the point is here, P, which is at a distance of 2 meters. Another point here, let us consider it as Q, which is at a distance of 4 meters from the origin. First of all, I am considering the point P. So let us calculate the electric field at the point P due to the charge plus 1 microcoulomb. Let us write this as EP vector, which is equal to, see what is the formula? 1 by 4 pi epsilon 0, the charge available Q by square of the distance or square. Along what direction? The charge is positive. So the EP vector that you are calculating at this point is acting away from that of the positive charge. That is along the positive x-axis. Positive x-axis is, I can consider it as I cap, plus I cap. Now substitute the value. But what are the values? Here, the value of Q is plus 1 microcoulomb is 10 power minus 6 coulomb. Then what is the value of the distance? The distance R is equal to 2 meters. Substitute it here. I can write EP vector is equal to, so I am writing 1 by 4 pi epsilon 0 into, instead of q it is 10 power minus 6 divided by 2 square I cap. When I am getting the values, it is 9 into 10 to the power of 9 multiplied with 10 power minus 6 whole divided by 4 I cap. On simplification, you see 9 divided by 4 multiplied with, on simplifying these two, it is 10 to the power of 3 I cap. You can leave as it is, or you can simplify and get the answer. When you are dividing 9 by 4, you will be getting it as 2.25 into 10 to the power of 3, and you have calculated what? Electrical field. The direction is I cap and the unit is Newton per Coulomb. This is the electrical field at the point P due to the charge plus 1 microcoulomb. That is subdivision A. Similarly, in the same subdivision, we have to calculate the electrical field at this point Q. So what to do? Write the next one. What is the second thing? The second one is you have to calculate electrical field at the point Q due to the charge plus 1 microcoulomb at the origin O. This is over. So let us consider this as EQ vector. What is that EQ vector? Again 1 divided by 4 pi epsilon 0 the charge Q by R square into. Here you see the charge Q is along the y-axis. So here you will be able to get EQ vector. In what direction this will act? The electrical field will act away from this positive charge. So it will be acting in the upward direction. Upward direction means positive J cap. So I can write the direction as J cap because along the positive y-axis. Now substitute. But what are the values? But the value of the charge Q is 10 power minus 6 coulomb. What is the distance? Here the distance is considered to be 4 meters. So let us write it out as 4 meters. Now substitute in this value and simplify. What is this value of EQ vector? EQ vector will be then equal to 1 by 4 pi epsilon 0. You can substitute as 9 into 10 to the power of 9. What is this Q? 10 power minus 6 divided by what is R square? It is 4 square. And the direction is J cap. Simplify, you will be getting 9 divided by 16 multiplied with here 10 power 9, here 10 power minus 6. So you will be able to get it out as 10 to the power of 3 J cap. On simplifying this, that is 9 divided by 16, you will be able to get it out as 0.56 into 10 to the power of 3 Newton per Coulomb, and the direction is J cap. See, you can write this as like this. In SI unit, we will be writing like this: 5.6 into 10 to the power of 2 along the J cap, along the positive y-axis, and the unit is Newton per Coulomb. So this is the subdivision A. Similarly, let us go for the subdivision B. What is the subdivision B? What they have given? The diagram again is, see, when you are considering this direction, you can say, see, at the origin, you are having the charge minus 2 microcoulomb. One of the point is taken to be P and the distance is taken to be 2 meter. and another point we are considering along the x-axis but on the other side, which is q, and the distance is taken to be 6 meters. If that is, here the electrical field is EQ vector and here the electrical field is EP vector. In what direction? You see, the charge placed at the origin is minus. So electrical field at this point will be acting towards that of the charge, that is minus x direction. Minus x direction means minus I cap. Similarly here, when you are considering the point Q, the electrical field at this Q is acting towards the negative charge. So acting this direction. So along the positive x-axis or positive I cap. Let us calculate the magnitude. So the first point, what we have to calculate? We have to calculate the electrical field at the point P due to the charge. How much? The charge is minus 2 microcoulomb placed at the point O. What is this charge? What is this electrical field? Let us consider it as EP vector, which is equal to, come on, say the formula, 1 by 4 pi epsilon 0 Q divided by R square. The direction of the electrical field is towards the charge or towards the origin, negative x-axis. So I am writing it out as minus I cap. Now you see, again let us substitute here. What is the value of charge Q? It is minus 2 into 10 to the power of minus 6 coulomb, and the distance R is equal to 2 meters. So what happens when you are substituting the value? You can get EP vector is equal to 1 divided by 4 pi epsilon 0 into, instead of Q, it is 2 into 10 power minus 6. I am writing only the magnitude. I am writing the direction at the final end. Divided by 2 square. Since the charge is minus, direction is towards the charge, negative x-axis. So I am writing it out as minus I cap. So simplify this. You can consider 1 by 4 pi epsilon 0 is 9 into 10 to the power of 9. Multiplied it with 2 into 10 to the power of minus 6 divided by, here you see 2 square, it is taken to be 4. Now on getting the direction, it is minus I cap. Simplify, what will be the answer then? EP vector is equal to 9 divided by, here 1 2, here 1 2, so I can consider this as 9 by 2. Multiplied it with, here 10 power 9, 10 power minus 6, it is 10 power 3 minus of I cap. So on simplifying, we get the answer as 4.5 into 10 to the power of 3 minus of I cap Newton per coulomb, or we can write minus of 4.5 into 10 to the power of 3 I cap Newton per coulomb. This is the first concept of the second subdivision. So we have calculated the electrical field at the point P due to the charge minus 2 microcoulomb at the point O. Similarly, we have to consider the next one. What is the next one? See, the next one is the in subdivision 2, we are going to study about the second problem, that is electrical field at the point Q. You look at the diagram in your notebook. Point Q due to what? The charge minus 2 microcoulomb at O. What is the electrical field? electrical field, let us consider it as EQ vector. What is the value? Formula is 1 by 4 pi epsilon 0 Q by R square. I have told that, see, origin is here, the charge is, the point is here Q, the charge is negative, so electrical field at this Q is towards the charge, so it is along the positive x-axis, so I am writing it as I cap. If it is the case, then what I have to do? I have to write the values. Here, the value of the charge Q is minus 2 into 10 power minus 6 coulomb. What is the second one? Rate distance. R is equal to 6 meters. So what happens on substituting? EQ vector is equal to 1 by 4 pi epsilon 0 into, what is this Q? By writing the magnitude alone, 2 into 10 power minus 6 divided by 6 square I cap. Now get the values. 9 into 10 to the power of 9 into 2 into 10 to the power of minus 6 divided by 36, which is equal to how much? Into I cap. So on simplifying, you can able to say that what? You can able to say this 2 and this 36 get cancelled. You can get 18, then this 9 and this 18 get cancelled. You will get 2. So on simplifying, what you will able to get? EQ vector is equal to, okay, EQ vector is equal to 1 divided by 2 multiplied it with 10 to the power of 3 I cap. What is this 1 by 2? It is 0.5 into 10 to the power of 3 I cap Newton per coulomb. So what is that? Oh, what is the? How we can write this? You can write like this: EQ is equal to, I can write 5.0 into 10 to the power of 2 I cap Newton per coulomb. It is not necessary that you have to write like this. You can write the answer as it is in the previous step, no problem. But usually scientific method, we will in SI unit we will be writing like this. Mantlisa part we will be having one digit and we will be putting the point and the remaining. So this is considered to be the example problem 1.6. Already we have studied up to 1.5 and this is problem number 1.6. Let us move on with what? Let us move on with the next problem in our next video. Okay, this is Newton per coulomb. Okay, next problem we will see it in our next video. Thank you.